Class 12th, subject physics, second chapter, mechanical properties of fluids. The term related with surface tension of liquid, that is angle of contact. So in order to explain the concept of angle of contact, here a glass beaker is filled with water and a glass tube open at both ends is dipped partially into it so that water will be in contact with glass, that is liquid is in contact with solid. So for a given pair of solid and liquid, the angle of contact will be defined. The angle of contact for a given pair of solid and liquid is defined as the angle between the solid surface, and the tangent drawn to the liquid surface, at the point of contact, measured inside the liquid or on the side of the liquid, is called angle of contact for that given pair of solid and liquid. Here the angle of contact is theta, that is the angle between the solid surface and the tangent drawn to the liquid surface at the point of contact measured inside the liquid. This angle of contact may be represented here also. So for that we can draw a tangent to that liquid surface at the point of contact, so that angle between this solid surface and this tangent drawn to the liquid surface at the point of contact will give us the angle of contact theta. Similarly, we can also denote angle of contact here, or here also this will represent the angle of contact. Now, depending upon the nature of the liquid and solid, the liquid meniscus will be having different shapes, and then angle of contact will be different for that given pair of solid and liquid. That is shown in this diagram. In the first diagram, this will represent liquid surface, this is the solid surface. The solid surface and liquid are in contact with each other at this point, so that here concave meniscus is obtained and the angle of contact theta is less than 90 degree, that is acute angle. Now this will happen only when this liquid partially wets this given solid. For example, kerosene in contact with glass will give us acute angle and the meniscus will be concave meniscus. In the second diagram, this is the liquid surface, this is the solid surface. Now liquid surface attains the convex meniscus here, and therefore when convex meniscus is obtained, the angle of contact theta will be here greater than 90 degree, that is obtuse angle. This will take place only when the liquid does not wet the given solid. Then example for this will be mercury in contact with glass. For the third case, the liquid surface is plane, this is the solid surface, and therefore if we draw tangent to this liquid surface at the point of contact, it will be along the solid surface, and therefore as tangent and solid surface are coinciding, angle of contact will be 0. This will be only when the given liquid completely wets the given solid, and therefore here angle of contact will be 0. Depending upon the nature of the liquid and solid, the shapes of the meniscus will take place as concave, convex as well as plane. That can be explained with the point shape of meniscus. Now, first one is concave meniscus, second is convex meniscus, third is plane meniscus, and fourth will be for any imaginary or hypothetical liquid for which angle of contact theta equal to 90 degree. So, to explain this shape of meniscus, we have considered here molecule A of the liquid which is in contact with this solid. In all diagrams, molecule A is in contact with this solid. Then around this molecule A circle is drawn here. Actually, it will be sphere, and that is the sphere of influence of this molecule A. Part of that sphere of influence lies inside the air, some part lies inside the liquid, and the remaining part lies inside the solid. And therefore, this molecule A will be exerted by, it will be acted upon by different forces. These are the cohesive forces and adhesive forces. The cohesive forces will be exerted by the liquid molecules, and the adhesive forces will be exerted by air molecules as well as solid molecules. And hence, in this diagram, AC represents, this is the AC that represents the cohesive force exerted by the liquid molecules. AP represents the adhesive force exerted by the solid molecules. Now, adhesive force exerted by air molecules on this molecule A will be negligible because very less number of air molecules will be present in this part of sphere of influence, and therefore only two forces are important, that is adhesive force AP and cohesive force AC. So in the first case, if you consider molecule A as it is acted upon by these two forces AP and AC, here the liquid which we have considered is partially wetting the solid, and therefore force AP will be larger as compared with force AC, and hence by completing this parallelogram we can find out the resultant of these two forces, that is AR. The resultant of these two forces AP and AC is AR, and it is directed inside the solid. But as there is no space to move these molecules of the liquid inside the solid, therefore wall of this vessel, that is solid surface, will exert opposite force on such molecules, and hence these molecules will move up. So that similar to molecule A, all other molecules which are in contact with the solid surface will be pushed in the upward direction, and hence the concave meniscus will be attained at the point of contact. Now, if we draw tangent AT to this surface, then it will be perpendicular to this resultant force AR, and therefore the angle between solid surface and the tangent drawn to the liquid surface at the point of contact, that is this angle between this solid surface and this AT, that is theta, which is nothing but angle of contact, and in this case angle of contact theta will be acute angle. So for this concave meniscus, vector AP will be greater than vector AC upon root 2. That is vector AP, that is the adhesive force, will be greater than cohesive force upon root 2. So that concave meniscus will be obtained here. Now go for second B, that is convex meniscus. In this case we have considered the liquid which does not wet the given solid. Again, different forces acting on it are the adhesive and cohesive forces, but as liquid does not wet the given solid, therefore the cohesive force AC will be very large as compared with the adhesive force AP, and therefore Again, if you draw the parallelogram and its diagonal, then the resultant force AR will be directed inside the liquid. Similarly, this resultant force will act on all the molecules similar to that of A, so that these molecules will be pushed in the downward direction, they will be pulled inside the liquid, and hence the meniscus will be convex meniscus attained here, and hence in this case the angle between the solid surface and the tangent drawn to the liquid surface at the point of contact, that is AT, this total angle will be equal to theta. It is greater than 90 degree. That means angle of contact will be obtuse here. Now it will be achieved only when vector AP is less than vector AC by root 2. So here vector AP will be very small as compared with this AC, and so that angle of contact is obtuse here and the meniscus is convex. Then go for third point, that is C, plane meniscus. In this case again, if you consider the forces acting on this molecule A, then the adhesive force will be very large as compared with this cohesive force, because in this case the liquid will completely wet the given solid, and hence adhesive force will be very large. Then if you consider the cohesive force, it is very small or sometimes it is negligible, and hence by completing this parallelogram, if we draw the resultant along the diagonal of this parallelogram, then it will be nearly parallel to AP, and therefore AR, that is the resultant force, will be nearly along AP, that is directed inside the solid, and therefore molecule A as well as all other molecules which are in contact with the solid at the free surface of the liquid will be pulled inside the solid. Therefore they will not move up or down, they will remain at their own position, and hence plane surface will be attained by it. Now in this case, if you draw the tangent to that free surface of the liquid, it will lie along the solid surface, and hence the angle of contact will be equal to 0, so that AP will be equal to AR. AP will be equal to AR, that is nearly same. Now instead of that, if you consider any hypothetical liquid, that is imaginary liquid, such that the cohesive force is nearly at 45 degree to that of free surface of the liquid, and AP is the adhesive force directed inside the solid, the resultant force of this cohesive force and the adhesive force, if it is along the solid surface, that is in the vertical position directed downwards, then the tangent drawn to the free surface of the liquid will be along the liquid surface, and hence angle of contact will be there 90 degree, that is this angle of contact is theta, because it is the angle between the solid surface and the tangent drawn to the liquid surface. Now this will be achieved only when AP equal to AC upon root 2. This AP equal to AC upon root 2 will give us the theta is equal to 90 degree, but it will be only imaginary or hypothetical.